It was a very short break. So welcome back after the short break. We're entering our last session for today. Before we go into the last session, I want to tell you what we're going to do afterwards as well. So after we have the next session, we're going to discuss also the activities that took place in the CTF. And after we do this, we're going to announce also the winners. So that is something left for the best at the end. But before that, let's talk about fabricating and generating events at scale. With the title, well, you know whatever it means. Please welcome to the studio, Mac. Mac, it's good to have you here.
All right.
And
Thank you.
We're all ready for you. Go ahead.
All right. Thank you very much. So fudge with me, you know, I've got it. I have no idea where I came up with that name, but it sounded like a very good name for a CLI tool. It's a Swiss Army knife for fabricating and generating events at scale. I'm Mohammed Makhlouf, but all my friends refer to me as Mac. And I am a co-founder and CTO at a company called Ronin Technologies. In today's agenda, I will be discussing a little intro about the problem at hand. Why would we need something like this? And how we would do it, how to do it. A particular choice around why I chose Rust as a programming language for developing this tool. Some things to consider, and I'll close off with the future that I'm hoping for this tool. First of all, a bit of an intro about myself. I am Mohammed Makhlouf. I am a CTO of a small security and a big data company here in Dubai. I am a distributed systems engineer at heart, but I'm a security engineering person by trade. I'm more of a defender type of a security person, so I am more blue team than a red teamer. And as one of the things that always fascinate me is addressing a lot of the security problems from first principles, from taking an engineering approach to addressing some of the security problems. In my career, I've worked on running security engineering teams, and I find that treating the security problem as an engineering problem is a very interesting way at looking at many of the security problems. And I've developed this kind of debugging philosophy from building kind of systems to do detection and response at scale, which is the most effective debugging tool is still careful thought and coupled with judicially placed print statements. It's a Brian Keringham code, and I live by this code. And doing distributed sort of detection and response at scale, most XDR platforms are a form of a distributed system, and trying to wrap your head around what is going on is a form of debugging. And it always feels something like this when you are debugging a distributed system. There's a lot of unexpected behavior from testing a lot of these systems. And the tool I've been developing is sort of helps kind of evaluate many of these kind of XDR detection and response type of systems. So first, we'll take a little step back and address what is the problem we are trying to look at here. If you are in a position to evaluate an XDR, an extended detection and response system that is collecting host events from any form of runtime, normally these systems come with an agent that you need to install on your runtime. And I use the word runtime here very flexibly because it could mean anything from a corporate endpoint, like a laptop, or it could be a production runtime. It could be an EC2 instance in your AWS machine, it could be a container running somewhere. It could be a transient workload, like a Lambda function that you want to observe events that took place there. And to provide you the ability of extended detection and response, you will be observing events that take place in those runtimes. I'm not going to get into the details of how XDR platforms are really built, and or if you are building one, what you would be looking at. But the gist of the idea is that you want to be able to collect all of those host events in a place very efficiently and effectively in order to be able to perform your detections and to perhaps automate some form of a response. And that normally happens by having an agent on the runtime. That agent is monitoring for events or observing for events that take place on this runtime. So this is kind of a very high level, very, very abstract view of the problem domain that we're discussing here. Normally, those agents that you install and set up, deploy a large fleet of those agents on all of those runtimes are looking for events that take place within that particular runtime. You'd be looking for file handles that open. You'd be looking for networking events. You'd be looking for processes that spawn. And you're trying to collect all this data and somehow perform some form of an analytics. So any XDR platform should be able to give you the ability to correlate those events and to make sense of those events. The problem we face if you are deploying a large fleet and you're testing some XDR platform is that you will want to have an environment to test this on. And everyone's solution to this is, well, let's set up a virtual lab. Let's make a virtual corporation. Let's install a bunch of virtual machines. Let's make up a fictitious network that we instigate some events on this corporate environment, and we test if this agent is able to detect some events that took place in this kind of fictitious environment that we made up. The problem with this is that it's very expensive, and if you want to actually test an XDR platform at the scale that we will be deploying in, say, a large corporation, where you are not only monitoring a corporate network, but also you want to monitor a production environment. You have maybe thousands of containers, you have thousands of servers, and you have runtimes that are transient in their nature, that come and go based on load. To mimic such an environment manually, it's a very tedious and difficult process. And so the ideal scenario is that I can do this in a very small runtime, and I can fabricate those events inexpensively without having to build a test harness like a virtual environment or a virtual lab to fake a fake corporation or a fake network or a fake set of systems that I want to test this agent on. And so there are a variety of events that we would want to be monitoring, and we want the agents to be able to see. And I want to be able to generate those events, to fabricate those events and have them really actually take place. But I want to do that in a very inexpensive way, and I want to be able to do them flexibly. If I am mimicking a ransomware, the behavior of a ransomware to mimic on a runtime is it would open, one way to detect it is that there will be a large count of open file handles at once. And it would be scanning, sifting through a file system. Mimicking the behavior on a runtime should be a simple thing to do, should not be a very complex thing. I do not need the rest of the fictitious corporation in order to mimic this behavior. And so there came the idea of writing this tool, which is Fudge With Me, You Know I've Got It, which is a Rust-based tool, which will build out a single compact binary that allows you to execute arbitrary code that is written in any programming language that can target WASM or WebAssembly runtime. So the idea is that to test the fabricated event, this tool will give you access to the underlying runtime, and you can programmatically decide how your fake kind of event generator, or say the fake malware that we are mimicking, should be written in any programming language that can target WASM, and you get access to a set of host functions that allow you to mimic those events. The constraints that we have here, that it should be very easy to mimic the behavior on any runtime, so hence the use of WASM, the WebAssembly. You can write code in any programming language to mimic the behavior of whatever malware or sort of outbreak problem that you want to mimic. It should be operationally simple to run this. I do not want to set up a large lab of fictitious corporate network to try to see if the system would work or not, and to test it. I want to be able to have this on a very small runtime, so I can do my entire testing inside of a serverless function. I can put the agent and this tool together in a simple runtime and mimic that behavior and have those behaviors actually registering in the underlying runtime and be able to see those events taking place. And the tool should be extensible, so we should be able to add whatever new behavior that we want to showcase and we want to test. Hence, again, back to WASM, and you can write code in any arbitrary code that behaves or mimics any behavior. And it should be really, really fast, because the point is to test this at scale and to generate a large volume of events to stress test the XDR system. And that's why I chose Rust to write this tool. Now, when anybody says their tool is a Swiss Army knife, they normally, the image that comes to your mind is the one on the right-hand side, which has a lot of capabilities, but it's actually not very usable. The current state of this tool is more like this very simple, small Swiss Army knife. Swiss Army knives come in a variety of sizes and functionality and utility. So, but the tool is extensible. You can write any number of behaviors, any type of behavior you want to mimic, and will give you access to the most important things, which are generating file events, generating processes or instigating processes of certain type, and network events. So we use a tool called Wasmer, which is a WebAssembly compiler that can run any WebAssembly bytecode. You can write the generator function in WebAssembly, and all you need is the WebAssembly bytes, the bytecode for the WebAssembly, and this tool. And given this WebAssembly file, handing it over to this tool and running it on any runtime, any flexible runtime, like let's say AWS Lambda, or on any serverless runtime, or within any containerized environment, and you can run the agents that you are testing off this any form of XDR platform that you want to stress test within the same runtime. The events that will take place, the tool will generate those events as per the generator function that you wrote, and it will register through your security agent that is installed within this runtime. The tool is written in Mozilla Rust. The choice of writing the tool in Rust was quite simple. Rust is a systems programming language. I'm a big fan of Rust. And some of the key benefits of writing this tool in Rust has a key phrase that you get to write systems programs that are fast, reliable, and productive, and you get to pick 3 of those things. You get to do fearless concurrency, because the garbage collection allows you and guarantees you that there will never be a data race in the programming language, the code that you write. And the language itself is community driven and is open source. It gives you a powerful type system, and it's quite useful in being able to express things much easier way. You have zero cost abstractions, so you're only paying for the things that you are using. You're not loading the entire standard library when you load a binary, so you can have a quite small binaries, and it gives you performance that's comparable to something like C. You get safe concurrency without the garbage collection, and that's thanks to borrow checker. I've been writing Rust for several years now. I've probably written almost 100,000 lines of Rust code in a production system, and I don't know how to use a debugger. And that's kind of I know it's not something to brag about, but I feel that's a good thing that in all this time writing distributed systems in Rust, I didn't have to learn how to use a debugger. Plus, my debugging philosophy is print statements. So, and there's a lot of great tooling for Rust to compile Rust programs and make taking a Rust program from coding, from development into production is really a breeze in comparison to something like, say, C or C++. Why we chose Wasmer for the generation function itself Wasmer allows you to write code in any programming language, and it will compile this code that you've written in whatever programming language of your choice into WebAssembly bytes, and you can target any runtime that you want to target. Any whether you're doing this within a containerized environment, or you're doing this even on mobile devices if you have an emulation for mobile devices. So you have that flexibility of being able to target any chipset that gives us portability that is quite hard to achieve otherwise. The tool is available on GitHub. It's Apache licensed. It's still a work in progress and will always be open source. We intend to develop this tool in the open. So the generator functions that we're writing to stress test different types of XDR platforms are all going to be available on this GitHub link. And we are looking for contributors to come help us develop these use cases and testing use cases scenarios using this tool. Thank you.
Okay, welcome back to the studio.
Thank you.
All right, so let's have some discussion around. So you mentioned that currently this is aimed at stress testing, right? So stress testing some solutions. Would this be also applicable since we're simulating and coming up with events, could it be also aimed at training detection systems? Because we are trying to inject something that is malicious, right?
Yes, definitely you can use this to improve your SOC capabilities. So if one of the reasons why it's difficult to make this testing is because if you are going to set up a whole bunch of virtual machines to mimic an environment, a training environment, it becomes quite expensive to do that. And with the use of this tool, you can do this entire kind of environment, fictitious environment where the events are being generated. You're paying for them by the millisecond if you run it on something like Lambda or some serverless provider from the cloud. And given that you can write any form of a generator function, the sky is the limit in terms of what forms of events you want to fabricate.
Right. So for us to fabricate events, we need to know what events are being triggered, and we need to describe them in a proper manner, right? And I think you already partially gave an answer. So what about if that would be a sandbox environment where we just drop a sample of ransomware and collect everything that's coming out of there, and then we inject it? Is that too expensive? It's not scalable?
I'm not sure malware developers designed it to run within a small runtime like the Lambda function. I have not tried that, but the general behavior of a ransomware, for instance, is that it would open a lot of file handles in your operating system at once. One of the key detection mechanisms is that there is a sequential access to your entire file system minus maybe the operating system files. Mimicking that behavior, that is the detection is going after that. So your detection set and your detection approach would be, well, there is a reasonable limit of how many open file handles should be within a single runtime at a time. So mimicking that part of the behavior of a ransomware is something that we can definitely do with this tool. And that will trigger and test your detection capability or your detection set.
Right. You mentioned Rust language. Does it have all of the support, the library support that you require? Since you're using it, I assume that the answer is yes, even though I understand that it's still the community is expanding, the support is growing. How do you find it?
I find Rust to be amazing. The community is very open and welcoming. There is a little bit of a learning curve to get into Rust, but the plus side of that, if you manage to compile a piece of Rust code, you will not be visiting it again for a long time. And to me, as a security person, but this is the flip side of this, having a guarantee that there will be no data races, that the code will not less likely to crash than if it was something that I wrote in C or in C++. And at the same time, we're getting the same type of performance from C and C++, and we don't have large GC poses, which is a problem with to write scalable things in Java and run a production environment in Java. I find Rust to be a treat to write code in a production environment and at that scale.
All right. Well, thank you so much for your presentation. Thank you for the work you've done for the community. I encourage everyone to check out the Mac provided Git repository to get access to the tool that you're providing. Well, thank you so much. Thank you for being here with us in the studio.
Thank you very much.
With this, we are going to take a slight break, and we will be back with you in just 3 minutes just to cover what happened in the CTF. So stay tuned. We'll be back in 3 minutes.